Today, we're digging into a cosmic mystery that redefines the very line between planets and stars. So let's get right to it. Where exactly do you draw that line between these two cosmic objects? Well, things in space basically form two ways. You either collapse from the top down like a star or build up like a planet. All right, meet our suspect, 29 Cygni b, an object so massive it completely blurs that line. Get this, it's 15 times more massive than Jupiter. Yeah, 15. And its orbit is huge. It's way out there, kind of like Uranus is from our sun. It's also still glowing hot from when it was born. That heat actually helps us see its atmosphere. So, how do you solve a puzzle like this one? Well, you need some pretty serious detective gear. The team used two heavy hitters, the Webb telescope in space and the Shara array on the ground.
So the plan was simple. Webb would handle the chemistry, and Shara would track its orbit.
Okay, let's look at the evidence. The first big clue came from its chemical makeup.
Webb found it's loaded with heavy elements, what astronomers just call metals.
And we're talking a lot of metal, the equivalent of about 150 Earths. Just, wow. All those metals strongly suggest it formed by gobbling up material in a planet-forming disk. But chemistry is only half the story. The second crucial clue was hidden in its orbit. And Shara nailed it. Its orbit is perfectly aligned with the spin of its host star.
Now, that alignment, that's a classic sign it formed from a disk, not from a random cloud collapse.
So you have two completely different pieces of evidence, both pointing to the exact same conclusion. So the verdict was in. There was no doubt about it. 29 Cygni b is a planet. This means it formed from the bottom up, piece by piece, just like the planets we know and love. And why is this such a big deal? Because it totally redefines how big a planet can actually get. Which leaves us with a pretty cool question. How many other superplanets are still out there waiting?